If you spend much time at the beach, you may notice that there's a difference between the sea breeze at night and the sea breeze during the day. And that comes from the heating of the land and the cooling of the land at night. So during the day, the land is going to warm up and there is going to be a breeze coming from the cool water onto the land, where at night, as that shifts, there will be an offshore breeze from the cool land to the warm water, just depending on night and day. Topographic effect. You may have heard this term orographic effect, or aura kind of means mountain, so it's the mountain effect. As wind blows from the ocean over mountains, that air is going to rise. That low pressure system then is going to carry with it lots of moisture, and so much moisture that there's going to be heavy precipitation. So that side of a mountains where the air is coming from, it's going to have lots of snow and rain. And then as the weather system gets to the wind, gets to the other side of the mountain, it's dropped all of its moisture, and it is now going to sink. It is now going to be a pressure system that creates high evaporation. So that is the orographic effect. We see that like in the Rocky Mountains, where the western side of the Rocky Mountains are pretty snowy and the eastern side are almost like a desert. All right, hurricanes are another weather phenomenon related to our ocean basins. These begin as, let's talk about hurricanes for the United States. They begin as storms off the coast of Africa. They are either side of the equator, not right at the equator like the doldrums. They're either side of the equator, and they're going to have different names depending on where they form. In North America, we call them hurricanes, but they're also typhoons and cyclones. It means the same thing. The sea surface temperature has to be warm, so in Celsius that would be 27 degrees. And there is that warmth is going to cause a low pressure system, and so the air begins to rise over that low pressure system, and as it rises, because of the Coriolis effect, it's going to start to rotate. So it's rising and rotating, and as it rises and rotates, there's going to be evaporation, and the wind is going to pick up as it feeds off of heat from the ocean, and so the ocean warmth kind of adds that energy. The warm surface temperatures from the ocean fuels the hurricane. Okay. These are paths of hurricanes, cyclones, and typhoons. So the green ones are ours. And notice for the Coriolis effect, we have that deflection to the right. In the southern hemisphere, the deflection is to the left. Those are hurricanes. With a hurricane, there is a storm surge. So the hurricane is going to be a low pressure system, very low pressure, and it is going to move across the ocean, picking up steam. This weird shape here is actually just showing like a cross section through a hurricane. So this is a hurricane cut in half. And what they're trying to show here is that the pressure is very low. It's going to pile up underneath the hurricane's eye, and therefore, so that there's a physical topographic high on the sea underneath the hurricane. It's elevated because of that low pressure. So when that comes into land, it's like a wall of water coming in with the eye of the storm. That's definitely made worse depending on the tide. So here is mean sea level, and 2 foot is the normal high tide. The storm tide is higher, and so it's bringing in a 15-foot storm surge with it. So always a storm surge. That physical elevation of the sea surface during a hurricane is made much worse if it happens during a high tide.